Buondì, anzi buonasera. Buonasera, siamo qui riuniti oggi per fare i nostri cari LeetCodes. Ok, quindi facciamoli entrare. Ok, scusate se sto digerendo ancora perché oggi tutto di corsa, ma ce la faremo. Allora, a parte che metto in carica il telefono. Olè. Allora, scusate, stavo vedendo un po' di analytics del canale, vi ringrazio perché comunque stiamo andando direi decisamente bene, soprattutto lato live, come potete vedere. Sono molto contento, 14.000 impressions, tanta roba, la media dei 1000 ogni volta che vado in live più o meno, con 300 visual, devo dire niente male. Quindi grazie. Ma non siamo qui a parlare di questo, siamo qui a parlare di LeetCodes. Cosa facciamo oggi? Andiamo avanti facendo in ordine binary search, sliding window e linked list, direi. Ok? Binary search, io direi come al solito andiamo prima a capire cos'è la binary search. Binary search di SA. Vediamo se troviamo for newbie. No. Cos'è sta parte? No, non è niente. Vediamo V3 School, che di solito è sempre interessante. Allora, ma qua vedi che c'è un po' di tutto? C'è un po' di tutto, DSA, 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 DSA. C'hanno tanta roba, DSA home. Direi che ce lo possiamo salvare. Ma noi andiamo in binary search. Che cos'è? Vabbè. The binary search algorithm searches through an array and return the index of the value it searches for. Ok. Run the simulation to see how the binary search algorithm works. We see that the algorithm goes to the middle and then to the middle and I think then to the middle. Okay. If you put 50, oh, we cannot put okay, 50, you will search for the middle here in the middle of array. Didn't find. Oh, it's finished. Ok. This seems pretty easy. Binary search is much faster than linear search, but required a sorted array to work. The binary search algorithm works by checking the value in the center of the array. If the target value is lower, the next value to check is the center of the left half of the array. This way of searching means that the search area is always half of the previous search area, and this is why the binary search is so fast. Ok. Let's zoom it a little. Ok. This process of helping the searches area happens until the target value is found, or until the search area of the array is empty. How it works? Check the value in the center of the array. If the target value is lower, search the left half of the array. If the target value is higher, search the right half. Continue step 1 and step 2 for the new reduced part of the array until the target value is found or until the search area is empty. If the value is found, return the target value array index. If the target value is not found, return -1. Pretty easy, no? Manual run through. Let's try to do search manually just to get an even better understanding of how binary search works before actually implementing it in a programming language. We'll search for value 11 here. The value in the middle of the array at index 3 is equal to 11, false. 7 is less than 11, so we must search for 11 on the right index of 3. The values to the right index of index 3 are 11, 15, 25. The next value to check is the middle value, 15, at index 5. 15 is higher than 11, so we must search for the left. We have already checked 03, so index 4 is only value to left to check. Okay, we have found it. Value 11 is found at index 4. Return in index position. Binary search is finished. And the simulation below to see the step above animated. We already saw it. Okay. Manual run through. What happened? To start with, the algorithm has two variables, left and right. Left is 0 and represents the index of the first value in the array. Right is 6 and represents the index of the last value of the array. Okay. Left plus right divided by 2 is equal to 0 plus 6 divided by 2 is equal to 3. So it's the first index used to check in the middle of the value is equal to the target. 7 is lower. So in the next loop the search area must be limited to the right side of the middle value on index 4 and 6. To limit the search area and find a new middle value, left is updated to index 4, right is still 6. 4 and 6 are indexes for the first and last values in the new search area, the right side of the previous middle value. The new middle value is 5, left plus right divided by 2, remember. The new middle value on index 5 is checked is 15, that is higher than 11, so if the target value 11 exists in the array, must be on the left side of the index 5. The new search area is created by updating right from 6 to 4. Okay, should be 5, not 4. Why is 4? If you were here for 6, you checked 5, so it's 4, yeah, of course. Correct. So there is only index 4 left to check. The target value 11 is found at index 4, so index 4 is returned. In general, this is the way the binary search algorithm continues to have the array search area until the target value is found. When the target value is found, the index of the target value is returned. If the target value is not found, -1 is returned. Okay? To implement the binary search algorithm, we need an array that is, remember, an ordered array, a target value to search, a loop that runs as long as left index is less than or equal to the right index. An if statement that compares the middle value with the target value and return the index if target value is found. An if statement that checks if the target value is less than or larger than the middle value and updates the left or right variables to narrow down the search area. After the loop, return -1 because at this point we know the target value is not be found. So the code should be like this. This is in Python. We have left, we have right. While left is minus or equal than right, we have to search it, check for the middle. This means in Python an integer, return an integer from this division. If array middle is equal to target value, return it. Instead, do this or do this. Okay, simple. What's the time complexity? For a general explanation of what time complexity is, visit the video. Okay, blah 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 blah. Each time binary search checks a new value to see if the target value, the search area is served. This means that even in the worst case scenario where the binary search cannot find the target value, it still only needs logarithmic and comparisons to look through a sorted array n of n values. So time complexity is log 2n. Now write this complexity using big O notation. We could also just have written logarithmic n. Okay? Okay. So we have logarithmic n binary notation. If we draw how much binary search needs to find the value in an array of n values compared to linear search, we have this graph. I'm a little... Okay. Random binary search simulation below the different value and blah 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 blah. Not important. Okay. We are always inside this logarithmic function. Okay. Okay, when you stop it, please. 3, 6, 9. This is the last. Okay. You can see. Okay. And these are some exercises. So pretty simple. Just remember left and right, and to check if we found the target value. Instead we have to upgrade the left or the right. Okay, pretty simple. I hope we will be very fast in this situation. So the first step is to solve the easy binary search. I think it's a standard. So given an array of integers nums which is sorted in ascending order, so it's already sorted, an integer target, write a function to search target in nums. If targets exist, they return its index, otherwise return -1. Okay? You must write an algorithm with O log n runtime complexity. We saw that the runtime complexity of binary search is O log n. Okay? This is pretty simple. We don't ask a question. Maybe the question we can ask is, are all unique numbers? Is sorted, you already said me. There are at least one element. Yeah, okay, perfect. So, there is always one solution? No. Okay, so what we have to do? We have a left index, okay, that equals to 0. We have a right index that's equal to the length of the array, of course, -1. Okay, this is the standard. Then while left, okay, or we can say better, when right is bigger than left, we exit. We return -1 at the end, and what we do now is to check the half every time. So int half. Okay, we can put it like that. I don't know. What we do is bam bam, that is left plus right, divide by 2. Okay, and then we search if nums half is equals to target, return half. Instead, if nums half is bigger than target, we have to put if it's bigger, we have to go on the right side because it's an ascending order. So left equals to half plus 1. Okay, we have to check on the left or the right side. Instead, we have to am I writing right correctly? Oh, okay. Equals to half minus 1. Okay, and that's all. That's all. Am I minus 1? No. That's it. What am I missing? What am I missing? I've been too sure. Okay, if I check here, I check oh, I missed something. Should be okay. I'm here, I check the 3, then I check 5, done. And if I check 5, I will check this and this. Sorry, just to take a look. What is the index of the half? Is 2. 0, 1, 2. Here. Blah 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 blah. Now write this 1. Oh, sorry. Yeah, no. Sorry, this is by reverse. The target is bigger, we have to go to the right. I'm sorry. This is when you go too sure of your result. Okay. If it's 5, the output is minus 1. Strange. I mean, the 0 plus 1 divided by 2 is 0. I check 0 and return 0. It's strange. No, target 5, sorry. The bug is not debugging. Hey. Why you're not debugging? What I have to do to debug this thing? Oh, okay. So you go inside. Oh. Yeah. I'm sorry. I'm sorry. We now understand why there were an equal. Sorry. That's okay. Pretty easy. Let's go next. Let's go next. So now we have searched 2D matrix. You are given an m per n integer matrix with the following two properties. Each row is sorted in non-decreasing order, so in ascending order. Okay. The first integer of each row is greater than the last integer of the previous row. Okay. Given an integer target, return true if target is in a matrix or false otherwise. You must try a solution in O logarithmic m per n time complexity. So we should check every array with the binary search to put inside to search the target. Okay, we expect, should I expect an empty matrix? No, there is always at least one per one elements. Okay, okay, so what we do now, same thing as before. So int left I would like to do in we have to return true or false. Okay, so what I would do is two whiles. The first while is the index of the row. I mean, what row of the matrix I'm searching, because if I arrive at the end, well, I have to know. If I finish to search here, I have to go next and next. Okay, so the first is a 4, and then in the 4 I put my binary search inside the 4. So for int r in row, that's okay. Yeah, for off, sorry, of in matrix, for off maybe, no, for in. Okay. Oh. Oops. For each int r in the matrix, what I do left int left l equals 0. Sorry. Int r equal matrix r dot length minus 1. Sorry. Int row is an int array row. Okay, then I have left right, and then the while left is minor equal right, we do int e equals l, sorry, divide by 2, l plus r, and then we search if row e equal target, we return true. At the end of all, we return false. And if row e is target, if target is bigger than row e, we put left equals, we go on the right side, so left is equals to the e plus 1. Instead, else right, we have to go to the left side, so equals e minus 1. Okay, should be correct. Okay, this is the first one, this is the second one, and so on. Pretty simple. Okay. I hope this is the correct m logarithmic n, so that's correct. M logarithmic n. Okay. So, pretty simple. Okay. Let's go next. Coco eating bananas. What we have here? Coco loves to eat bananas. There are n piles of bananas. Here is it. How I read it? I don't know. Piles bananas. There are n piles of bananas. Iesima pile bananas. Okay. The guards have gone and will come back in 8 hours. Coco can design their bananas per hour, eating speed of k. Each hour, she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead, and will not eat any more bananas during this hour. Okay. Coco likes to eat slowly, but still wants to finish eating all the bananas before the guards return. Retard the minimum integer k such that she can eat all the bananas with 8 hours. Okay. This is pretty difficult. I think we have at least one banana, one pile of banana. I think that's correct, and h should be equal the length minimum. because she wants to eat all. So there are n pile of bananas. The iesima pile as piles di banana. Ok. This has 2 piles of banana. Ok. Ok. We'll come back in each hour. And Coco wants the minimum speed. So she chooses some pile of bananas and eats key bananas from the pile. If the pile has less than k bananas, she eats all of them instead and will not eat more bananas during this hour. She's choosing some pile of bananas. So how I can choose the target? Okay, let's think to a way to solve this. I have an array of integer. I want to finish all, so I need to know the sum of all the array. Is the array ordered? No, it's not ordered. Each hour she chooses some pile of bananas and eats k bananas from the pile. I know the hour. Every hour let's put in numerical way, okay? Let's do a test. Okay, like 1, 2, 3 and 4 to do it in 1 hour. For every, it's not important how much piles I have. To do in 1 hour, I have to eat all the bananas in the hour. Okay? If I have to eat in 2 hours, I must eat half of the bananas in 2 hours. This is the problem. Okay? This is what the problem wants. Then I have 5 hours, all the bananas divided 5. This is what I think. This is the minimum number of bananas to eat per hour. But there is a problem, because if I choose 1, for that hour I can only eat 1 banana, not 1 more. So let's do 4 and 4. I have I have 7, 9, 10 bananas. Okay, I have 10 bananas. Let's do 5. No, I have 10 bananas. Okay, the minimum K per hour to eat all the bananas can be, should be, if I do a check like 4 divided 2, sorry, 10 divided 4 is like 2 5, okay? But if I do like that, I eat 2 bananas here and I stop. Then I eat 1 and I stop. I eat 2 half, I'm full and stop. I eat 2 half, I'm full, I stop. I finish the hours and I cannot complete it. So the minimum must be higher, like 3. With 3 bananas per hour, I go there, I eat. Second hour, I eat it all. Third hour, take it all. 4 hour, I miss 1. Okay. So the minimum must be 4 in this situation. Because I eat 4, then 3, then 2, then 1. So if I have same hour than the length of the pile, I have to eat the maximum for hour. The maximum of array, so let's put this as a rule. Assumption as 1. If h equals to piles dot length, result is max of piles. Okay, then if hour is 8, I think I can do half. Okay, the sum is not important. I think we have to look at the 8 and at and the length, sorry, non è h hour, the hour and the length. If we saw 8, what I do, I can eat 2 per hour. Why? Because I can eat 2 of this and that's okay. 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 So I passed 1, 2, 3, 4, 5 and 6. So I can eat 1.5 maybe. Okay. In 2 hours I eat this. In another 2 hours I eat this. Other 1 hours, and there are 5 hours. And here other 3 hours to eat this. Okay. So it's like always 8 divided piles length minus something. What if I do 10 divided 8? Okay, maybe 1.25. I don't know. Allora, if I have 10 hours and the sum inside is 10, I should be able to eat 1 per hour. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So another rules is this: if h equals to max piles, result is 1 always. Okay, I'm trying to find constants to be able then to get some result. I have to return an integer. Yeah, I have to return an integer. Let's do some other test. If I have 1 and I have 2, the result is 0.5. Okay, if I have 4 is 0.25, of course, but I think I will always have at least this, and it's 1 per hour. In this situation, it's this is 2 per hour. I ate 2, I ate 2, I ate 2, I ate 2. So if pills.length is equals to 1 and if piles equals to 1, I have to do h divided piles of 0, the element, of course. So it's not important the order in the order of eating, so I can order all the array. What I have to do then is to search for all the bigger one, and divide the bigger one for the hours. But when I order it, I already know that the bigger one is the last one, so it's not this a good approach. This is not a good approach. Okay, I found it. These three. Let's try to search for other rules with the samples, okay? With this array, and hours equals to 8, the result is 4. Is 4 why? So these rules, we already find these rules. When the pile's length is equals to the h, to the hours, sorry, this result is the maximum, and we are here. If the pile's array is minor than the hour, we have to find the situation. Okay. So in the case where here we have 18, 21, 27, 27 is not a number, an interesting number for now, but the length is the half of the hours. If the length is half of the hour, maybe can be the response is half of the hour. I don't know. I'm not convinced. If it works for this and for this, maybe can be. So here the result would be 4, 4, 4, and 4. But if I have an 8 also here, 4, 4, 4, 4, and 4. It's not correct also for this. For this situation, I think it's 2. 1, 2, 3, 4, 5, 6. No. For this situation is 2. How I know that this is 2? I have 1, 2, 3, 4, 5, and 6. There's something, I think there's something with the sum and the length. How I find that this is 2 in an arithmetical way? Res is 2. But how? Let's think. Sum is 10. Len is 4. H is 6. it's an interesting LeetCode. Am I going far away? Let's try to ask for an hint. No, we don't have hints. So, what am I missing here? I missed the... These are the edge cases. Okay, I'm missing the rules, the generical rule. That is the most important. Else, this is else. What I have to do in else? I'm missing the most important part. Okay, let's try to break down this. If I have this situation, okay, here the response is 1. Here the response is, we saw, is 4. Here the response, let's put 5 is 5, okay. Here the response is, we said, this is not correct. This is maybe else safe, because if I have this and I have this, result is max file. If I have this, sorry, in this situation, if I have the sum of bytes, result is 1. Okay, now I can understand. If I have this situation, result is 2. If I have this other situation, is always 2. No, sorry. This situation is 1 because it's like the maximum. If I have 1 in multiple hour, it's always this number divide 4. Of course. Yeah. So is always piles divide x and non the inverse. Ok. If I have two elements, what if I have two elements and the number is 5? I don't know. This can be 2 per hour in 4 hours because this is easy because it's a double. This is the sum divided 5. But here is not correct because 27 divided 8 is 3 point something. And this situation 10 divided 6 is 1 point something. I'm not sure we must do the sum divide this. We can try, I mean, we can try. We can try to put something like that, but now with this situation, I know that the problem should be solved with the binary search. I'm not searching for nothing. I am not searching for nothing. Okay, let's try. I mean, let's try. I'm pretty sure it's not a good one, but okay. So if h equals pairs dot, let's put exactly what I did here. So result is mat.max piles return, sorry. Then if h equal I don't know if I can do that, but okay. Just to remember what I have to do, result is 1. If by length equals to 1, the number is h. Sorry, is piles divided h. Altrimenti else sorry, I don't think that this is exactly max of array. I'm not implementing that because I want just just because I know that it's not something correct. Okay, there are also some. Let's see if it's okay. I think yes, but no, I'm not sure. Okay. This is not correct, of course, but if I do this, it's also not correct. Exactly. So this is not the correct way. I'm sure it's not the correct way. I'm in difficult. I have the difficult to understand what is the solution, really. I think this is the pretty first time I have no idea on how to solve it, really. I even check here. With 5 we saw it is 30 and that's okay. With 8 I don't think I have a brute force approach or something similar. Like divide it. Bam, bam, bam. I don't know. I really don't know. Why this is 23 per hour? 58, 69, 73, 93. 93 divided by 23 is 4. 96 is 1, 5. 93. 6 hours, the number is 23. I'm not understanding. Really? I'm having difficult. I don't know. This is out my... I really don't know, really. Sorting is not required. K is banana per hour, H is number of hours. For example, 1, 3 is less than K. Only 1 hour is added. The serious pile took 1 hour. Since 6 is greater than K, Co can eat K from 6, leaving 6 minus K, 2 bananas left and adding 1 hour. Since 2 is less than 4, add 1 hour. Okay. The first pile took 2 hours. Add 1 hour. The second pile took 2 hours. Since 11 minus K, add 1 hour. Pile took 3 hours. For a total of 8 hours, that equals H. There's a faster way of doing the above that doesn't involve subtraction. Given piles H5, if K equals 30 banana per hour spent is 1 per... given piles, if K is 23 banana per hour spent are 2 and all 1, for a total of 6 hours. And so I have to find the... I have to find what? Eight minus 4, that is the length. Eight minus 4 is 4. 6 minus 5 is 1. So the question is, while the hours I pass... Ciao, mi trovo in un momento di difficoltà. Allora, stasera LeetCode come al solito, come ogni sera, ma su su dei problemi relativi alla ricerca binaria, che pensavo di aver masterato fino a pochi secondi, fino a qualche minuto fa, in quanto sto problema è un vero macello a livello logico. Cioè, ho trovato un po' di punti. A Google se riesce a entrare. Il 22 lo sapremo. Il 22 avremo un piccolo primo passo. Vedremo. Non credo, ma vedremo. Termine search for the solution space. Given if la dedicata please. Farò una live dedicata, non lo so, nel senso che magari posso fare sì una live dedicata a quello a che succede nel colloquio, ma col fatto che sono sotto NDA e col fatto che fare un colloquio mentre lavori da un'altra parte non è proprio il massimo, forse eviterei. Però sicuramente vi farò sapere, quello sicuramente sì, quello è sicuro. Cercherò di dire la mia su quello che succederà. Io quello che mi aspetto, l'avevo detto forse in un'altra live, quello che mi aspetto è di passare il 30% delle volte. Credo che arriverò lì che una volta su 3 lo passo il colloquio e 2 volte su 3 no. Quindi non credo di passarlo. Però è già una bellissima esperienza, devo dire. E mi preparerò bene per tutto l'anno per passarlo poi tra un anno. Allora. Cerchiamo di concentrarci su questo problema che mi sta a togliere l'anima. Try binary search over the solution space given a fixed speed. Ok. It's easy to check if Coco can eat all the bananas within 8 hours. If it works for K. If it works for K, we recurse by setting right. No, it's not convincing me. So, che programma uso? Al momento stiamo programmando in C#, però in realtà conosco JavaScript, conosco Java e Python non lo utilizzo a livello professionale, lo conosco più o meno, alla fine una volta che conosci il linguaggio li conosci tutti. Poi non sai magari la sintassi, tipo che ne so, come si fa a trovare il massimo di qualcosa. Qua si scrive in questo modo, mentre magari in Python si scrive in modo diverso, però il succo della logica è sempre lo stesso. Quindi alla fine, per quanto mi riguarda, conosci il linguaggio non è tanto importante a livello lavorativo, cioè una volta che sai più o meno la base. Qual è più facile? Qual è più facile? La risposta giusta dipende da quello che devi fare. Cioè, nel senso, forse il più facile di tutti è JavaScript, perché non c'hai troppi problemi con la tipizzazione, non c'hai... è abbastanza veloce capire quello che stai facendo, è abbastanza intuibile. Tra JavaScript e Python sono quelli un po' più veloci. Infatti di solito alle scuole è quello che si fa di più. No, Google funziona che tu fai domanda a Google generico, non hai la sottosezione Italia. Tu fai domanda a Google per una posizione che può essere in Europa, può essere in Brasile, in India, in America. In Italia in realtà non hanno posizioni aperte per quanto riguarda gli sviluppatori, ma solo per quanto riguarda lato commerciale delle volte, ma è molto raro trovare posizioni in Italia. Io solitamente faccio application per la Svizzera, anche se la Svizzera è quella che il più delle volte viene saturata subito perché ci sono tutti gli interni che si fanno spostare tutti gli interni europei si fanno spostare dall'Europa alla Svizzera perché si guadagna di più fondamentalmente. Però non c'hanno questa differenziazione tipo altre multinazionali. Per esempio nel lavoro dove sto adesso esiste la controparte italiana, la controparte sì, perché questo è per le live di quando faccio lavoro normale. Infatti lo dovrò impostare bene il bot, ma non c'ho mai tempo. Comunque, per esempio, la multinazionale dove lavoro adesso, io sono nel reparto italiano, nella controparte italiana, che è quasi una società distaccata. Cioè, mentre Google è globale proprio a livello di application e tutto, non c'ha differenziazione anche quando lavori lì. Presumo, non lo so. Comunque. Non ho capito questa cosa. Cioè io do una speed che è K. E visto che devo trovare la minore, parto con 1. Se easy check if cover need all the parameters se 1 non va bene, we recurse by setting right key. Let's create plus 1. Sì, dipende, guarda, mi ricordo che anche con le live era, perché mi sa poi sei uscita a un certo punto. Ero in chiamata, mi sa che era una live in cui una certa tu mi dicevi tipo non ti sento, perché ero in chiamata. Infatti sto periodo mi stanno bombardando di chiamate, quindi alla fine non riesco mai a fare le pause. Cioè dovrei fare le pause del pomodoro timer, se non serve a niente che c'è il pomodoro timer, ma non riesco sto periodo. Proprio perché sto sempre in chiamata, costantemente, quindi quando vedete che parlo e non si sente... Sì, mi ricordo perché mi è rimasto impresso. Che quando vedete che parlo e non si sente è perché ho il microfono o perché mi sono scordato di smutarlo, ma molte volte è molto più facile che sto in chiamata e quindi in realtà sto facendo proprio altre cose, sto parlando di altre cose e ovviamente non posso farle sentire, quindi devo mutarmi per forza. Sì, si sente? Che so di Roma. Roma Est. Sono di Roma Est. Non so se conosci le zone. Ancora per un po' siamo di Roma, sì. Allora, lui sta dicendo, torniamo un attimo al problema, se no qui non finisco più e non dormo mai. Allora. Provo a tornare in inglese. Perché dobbiamo prepararci bene. So, the int is to do a fixed speed key that I think I will start with 1, I don't know, and comunque se vuoi consigli su inglese può provare ad aiutarti, tra un mese inizia a figo, dai. Io penso di essere decente in inglese, la pronuncia no, riesco in realtà a leggerlo e scriverlo correttamente, scriverlo in parolone, comunque diciamo che riesco a capirlo e a farmi capire, però sì, molte volte mi mancano le parole, cioè c'è proprio delle mancanze a livello di vocabolario in inglese. Infatti ho cominciato a leggere qualche libro in inglese, anzi in realtà c'è stato un piccolo periodo che riprenderemo a gennaio in cui nella pausa pranzo leggevo un libro in inglese, qualche capitolo del libro in inglese e poi lo provavo a spiegare a parole mie in italiano. Sicuramente lo riprenderemo questa cosa da gennaio. Beh, buona fortuna per l'esame. E quando ce l'hai però l'esame? Se inizi tra un mese... Boh, quanto dura il C1 come preparazione? Non ho idea. se if we start with 1, 31 gennaio faccio il B2. Ah, quindi finito il B2 poi parti subito col C. Figo. Col C1. Quindi rispari tutti di fila. Vabbè, fai bene in realtà, così almeno sei fresca. Ci può stare. Ma lo fai per, diciamo, certificazioni personali, motivi lavorativi? Vuoi provare ad andare all'estero? Non lo so. Scuola tua è fatta così. Una scuola... Che scuola fai? Fai una sorta di lingue. Linguistico Cambridge. Allora, scusate per chi vedrà la live postuma, è interessante. Questo. Aspetta, non voglio magari mostrare indirizzi e cose varie. Basta, quindi fai tipo 3 lingue. Beh, sembra figo, dai. Allora. Sembra interessante. Il massimo che ho fatto era il B1 forse. Non so, ma tipo alle medie. Comunque la batteria della è migliorata. Adesso sono contento, meglio. Magari hanno stabilizzato. Io ancora devo aggiornare. Non credo che aggiornerò a iOS 26. Sto aspettando il più possibile finché non mi costringono. Però ci può stare. Comunque devo tornare assolutamente a concentrarmi, anche per il rispetto di chi vedrà la live futura, dicendo qua stiamo facendo tutto tranne che LeetCode. Quindi, allora, andiamo avanti. He's saying to search, to use binary search with a key that is fixed, and I think I have to, if it works for k with regards for setting right equals to k. So it's going by reverse. It's going from the maximum to the minimum of the k. Instead, we recurse by setting left equals k plus 1. Okay. Ah, okay. So, what is he saying is, we can, it's not important all this situation. Ah, assolutamente, vai. Non preoccuparti, grazie per essere passata. Ciao, alla prossima. Buona serata. Allora. What we do, what he's saying is, I go for k equals to last element, and then I do h, k divided h, ok, che di quarto del max, e faccio k divided h, ok. Fixed speed. What speed? Cannot be this. Maybe something like that. No, I'm losing this. Oh, I'm close, but I'm losing this. In the problem, Coco is given n piles of bananas represented by an integer array of length n. She eats at constant speed, for example x bananas per hour. The time taken to eat a pile of y bananas is y divided x, after rounding up to the closest integer. For example, if she eats 3 bananas per hour, it takes 2 hours to eat a pile of 4. The first constraint of the problem is that Coco has to eat all the piles within h hours, where h is no less than the number of piles. We can imagine that with a fast speed, Coco spends 1 hour on each pile. Therefore, she can always finish all the piles within h hours. Let's call this kind of speed workable speed. Likewise, let any eating speed at which Coco can't eat all the piles be unworkable speed. However, we have another constraint that Coco would like to eat as low as possible. Therefore, among all the workable speeds, we need to find out the minimum one. How do we calculate the overall time for Coco to eat all the piles? Let's refer to 2 examples before. I eat 5 bananas per hour, guards return in each hour. Current time 3 divided 5 is 1. 6 divided 5 is 2. 7 divided 5 is 2. 11 divided 5 is 3. Total time is less than or equal to 8. 5 bananas per hour is a workable speed. Why you choose 5? I don't understand this. Does the order by which Coco eats affect the overall time? No. The order does not matter because Coco will stop it for the rest of the hour, even if there are no more bananas left. Therefore, the time she spends eating a particular pile is given as current time equals number of bananas divided speed. Regardless of the order of this pile in her eating plan, thus we can conclude that as long as the eating speed is the same, the order of the piles by which Coco eats does not affect the total hours, so we can keep the array as it is for convenience. The brute force approach is to try every possible leading speed to find the smallest workable speed. Start it from speed equals 1 and increment it by 1 each time. We will find the speed at which Koku can hit all piles within 8 hours. That is the first minimum speed. So the minimum speed is 1. Maybe I'm understanding. The minimum speed is 1. Maximum speed is the maximum elements. Okay? Because I eat it all. Then I try to get in the middle. If I construct an array that is from 1 to the maximum, I construct an array that is 1 to the maximum, and then I try the best, I don't know. Start at speed 1. Given the current speed, calculate how many hours Koku needs to hit all of the piles. If Koku cannot finish all the piles each hour, increment speed by 1. Speed plus 1. Let's start over. Retard the speed. It's included because it's an intuitive first approach, and it helps lay the foundation needed to understand the following, optimizing the approach. Where it's a brute force approach and it not expect to pass all the test cases. Let n be the length of the input array piles and m the upper bound of elements piles. The complexity is O n for m. Binary search. In the previous approach, we tried every smaller reading speed before finding the first workable speed. We should look for a more efficient way to locate the minimum workable reading speed. Recall how we calculated the total time for Koku to finish eating all the piles in approach 1. We can observe two laws. If Koku can hit all the piles with the speed of n, she can also finish the task with the speed of n plus 1. With a larger eating speed, Koku will spend less or equal time on every pile. With a larger eating speed, Koku will spend less or equal time on every pile. Thus, the overall time is guaranteed to be less than or equal to that of the speed. Why am I saying speed? Okay. If Koku can't finish with the speed of n, then she can't finish with the speed of n minus 1. With a smaller eating speed, Koku will spend more or equal time on every pile. Thus the overall time will be greater than or equal to that of speed n. Given the previous law, the distribution will be: in the current speed is workable, the minimum workable speed should be on its left incursively. If the current speed is not workable, that is too slow to finish the eating task, then the minimum workable speed should be on its right exclusively. We can use binary search to locate the boundary that separates workable speed and unworkable speeds to get the minimum workable speed. First, let's set a reasonable upper and lower bound for binary search to ensure that we don't miss any workable speed. Let the lower bound be 1. The upper bound will be the maximum eating speed, that is the maximum number of bananas in a pile. For instance, if the piles are, then 9 is the maximum number of piles. Because Koku can hit every pile within an hour, speed of 9. Okay, so this is correct. What I was doing is correct. So I have min speed equals 1, int max speed equals piles max. Now I have to search in this middle. Once we set the boundaries, we can then apply the binary search to reduce the search space. In each iteration, we will reduce the remaining search space by half until we have narrowed down the search space to just one element, which is the minimum workable leading speed. There are many other interesting problems that can be solved by performing a binary search to find the optimal value. You can practice using the binary search approach on the following problems. Okay. In scenario to boundaries, search as left and right. Okay, let's try to do the same. Left, right. Get the middle value. This is Coco eating speed during this iteration. So we do a while true and we do also this right, sorry, left, right. Maybe I found. Oh. Now, if iterate over the piles and check if Coco can eat all the piles within each hours, giving the eating speed of middle. We know because we do P divided H, right? Just try to understand if it's okay. Okay, if our spent is bigger than, I am almost cheating with this. I'm almost cheating. Drag this for each. Okay. It's not a good approach. Iterate over the wheel and check if goggles can eat all the piles within 8 hours, given this eating speed means. If Coco can finish all the piles within 8 hours, set right equal to middle. Signifying that all speeds greater than middle are workable but less desirable by Coco. Otherwise, set left equal to middle plus 1, because we need to segnalare the speed less or equal than middle not workable. Okay, yeah. Repeat step 2 and 3 and 4 until the two boundaries overlap, left equal right, which means that we have found the minimum speed by which Koku could finish eating all the pies within 8 hours. We can return either left or right as the answer. So now I have to check how to do this in C#. Come on. Interesting. It's not fucking working. Why? Okay, maybe this is the one. No, it's what the fuck. I've written the same code. I wrote the same code. I literally wrote the same code. What the fuck? I don't know, I'll submit like that. I cannot understand why. And log m. What is going on here? is true. This is true. Is my idea to this approach where I don't read. I don't. We'll try to do like that. And I will not need this. What the fuck? Okay. I'm just saying, okay, that's okay, that's okay. That's enough for today. Yeah. We did 3. And that's okay. That's okay. Now we are at 57 submission, 50% acceptance, 21 problems, and okay. How about Google? How about Google? We have solved 16 out of 140. Okay. Oh, specific Google LeetCodes. Well, I have 1 week to do 130 LeetCodes. Okay. See you tomorrow. With this bomb notice, like, I don't know if you know, I hope you know YouTube. Oh, come on. Oh, come on. You don't have it? What? Oh, come on. So we don't have the final No, I want the phrase. Come on. Oh, e con questa notizia bomba. Ok, I left to download the Shin and I'll use it every time we finish the live. I'm saying that. So, thank you all for being here. Grazie a tutti per essere stati qui. Vi ringrazio veramente tanto. Ci sentiamo domani live durante il lavoro e poi la sera LeetCodes a non finire, sperando di farli tutti e quattro, dai. Speriamo di andare avanti più veloce perché sennò non ce la facciamo. Quindi sabato e domenica devo mettermi sotto a manetta perché sennò non ce la faremo, ragazzi. E io vorrei arrivare almeno fino a qui, che c'è il dynamic programming. Almeno fino al dynamic programming, perché sennò è proprio completamente inutile farlo. E con questa notizia bomba ci sentiamo domani.